This is Higher Maths, it's practice paper E. We're looking at question 24 in the non-calculator paper. We have a function f of x defined here, and what we have is a range that we're going to have to work between. So it's between 0 and 3 included for the values of x. We have to find the maximum and minimum values of f. Now we've got to be careful with this type of question here, because if we're looking for a maximum or a minimum value on a function, it either occurs where there's a stationary point, so we'll do that work, or it will be at the end points here of the range, so the 0 or the 3. So we have to include these in the calculation to work out the maximum or the minimum values before we make our final statement. Right, let's go ahead and we'll try and work out where the stationary points are first of all. So let's start off with the function. Okay, we've got x cubed, we've got minus 2x squared, we've got minus 4x and plus 1. Okay, so when we're trying to find our stationary points, what we'll do is we'll differentiate. So we'll find f dashed x, and that'll be 3x squared minus 4x, and that'll be minus 4. Okay, and just remember for stationary points, what we've got is we've got f dashed x this time is going to be equal to 0. So I'll substitute a 0 in where I see f dashed x. And what we'll do is I'll just go straight, and what we'll do is we'll factorise this part out here. So I've got 3x and x, and for the 4, what we can have is 4 and 1, or we can have 2 and 2. Let's go for a 2 and 2 that's here, okay? And from here, I know that that's going to make up 6, that's going to make up 2. This one here will be the minus, this will be the positive. From here I can see that 3x plus 2 equals 0, so x must equal to minus 2 over 3. Bring a 2 over, divide by the 3, and over here I've got x minus 2 equals 0, so x equals 2. So what I've done there is I've found two x values of stationary points. If I go back up and look at the range though, this one here is between 0 and 3 for x, so this value here is out of range. And I'm not going to use that value. I'll talk about that towards the end of the question. We'll have a look at this value that's here as well. Right, so let's have a quick look and see if this is a maximum or a minimum point. Right, so let's just set up a table. A nature table here. So what I've got is I've got a value of x here. I'll go with 2, and a value coming up to 2 will be 1. A value going away from 2 will go with 3. So if I look at f dashed x in here, that value there will be 0. I've already set it at 0, and if I substituted a 2 into the gradient equation, or the f dashed x, then I'll get 0. And I'm going to get a negative if I substitute 1 into this here, and if I substitute 3 in, that's going to give me a positive value that's there. Okay, so the shape of the curve at the point where x is equal to 2, so it's going to be negative. It's then going to be flat, and then it's going to be positive. So that's going to be a minimum, and that's at x equals 2. Right then, so let's go ahead and see what other work that we need to do there. So we've only found out a minimum, and that might be the answer for the minimum value. It might not be once we work out what the f is, once we substitute the 2 in. So let's go and find out what f is equal to when we substitute a 2 in. So I'm going to go back up to the original equation, and all I'm going to do is I'm going to substitute the value 2 in, and that's going to be cubed, that's going to be minus 2, and that's 2 squared, minus 4 times 2, plus 1. If I work that through here, what I've got is I've got 8 minus 8, so they cancel out. I've got minus 8 there plus 1, so that's giving me a value of minus 7 when I work that one through there. Right, so what I did say was that the minimum and maximum values are going to occur either at stationary points or where we take the end points of the range. So let's go for the end points next. So we'll try a 0 in here. So it'll be 0 cubed minus 2 times 0 squared, 4 times 0 plus 1, and that's just going to work out to be 1 from there. And let's do the other end of the range. So it'll be a 3, so it'll be 3 cubed minus 2 times 3 squared minus 4 times 3 plus 1. Okay, so 3 cubed is going to be 27. I'm going to take away from that, that's going to be 9, 18, take 18 away. subtract another 12 and add 1, so that should give us a value of minus 2. So that's minus 2 appearing there. Right, so from there what I can see is that the lowest value that I've got here is this one here. So this one here will be my minimum. And the highest value, the largest value of f that I've got is 1. So that there will be my maximum value. Okay. So what I'll do is just make a final statement. And I'll say that, let's see, the maximum value of f is equal to, and the maximum was 1, and that was when we've got x equal to 0. Okay, so that's our maximum value. The minimum value, so the minimum, the smallest or the lowest that it gets to is minus 7. It's equal to minus 7, and that's when x equals 2, when I substituted 2 in. That's 2. And that'd be the question complete there. Okay, so what I'd like to do is just to have a look at the graph of this function. So I'll just draw it very, very roughly. Okay, so what we've got is I've got x values going along this direction, y values going up this way here, and let's see, what points did we have? We've got 0, 1, so I'll say that was 0 and 1 there. We have, let's see, 2 and minus 7, wasn't it? 2 minus 7, so 2, and can I just say that that's about minus 7 there? So that'll be 2 minus 7. Okay, and for 3, what did we get for 3? We got 3 and, let's see, minus 2. So that would be there. So that would be 3 minus 2 there. That would be 0, 1 there. Okay, and what we've actually got with this curve would come up, and this value here, the minus 2/3, which would be out here somewhere, would be a value up about here. I think it would be about 2.5, roughly 2.5 for this one. So this curve here will go up, okay, it'll turn here, it'll then come back through here. Oops, not a great drawing, but just to give you an idea what's happening here, and that curve will go all the way up there. So remember what we were asked for at the start there, the limits that we were given, or the range was between 0 and 3, so the range that we're given is between here and here. Okay, so that there is the range that we're interested in, just from there to there. The range. Obviously, there's some higher values away up here, okay, than this one. There's a higher value there, and I'm sure there's lower values away down this way here than the minus 7. But because this is the range that we're really interested in, these are the only values that we can take, and as such I'd be very, very careful with this type of question when you see this one coming along in the exam. Right, let's go for some of the marking for this one here. What we'll go for first of all is we'll go for differentiating, knowing to differentiate to find the values for the x values for the stationary points. I'm just going to give a value here for getting these two, okay, and I'll go for one value for 1 mark for working out that when I substitute 2 in I get minus 7, and I'm going to give 1 mark for considering the 0 and the 3, so both of them must be considered to get this mark here. So that's 4 marks already, and finally last mark for making our statement. Okay, so that would be out of 5 marks, and 1 to be extremely careful of.